Okay, on Monday, we did an example of just graphing the parabola, the x-squared. It was a little rushed, I'll admit. So I'm going to break down all the graphing in class today. I'm going to kind of set it up over there on the side. That's not on the screen right now. But I'm going to set it up so you can see the steps for it. The graphing on your exam is going to be based on multiple choice. Okay? You're not going to have to graph it by hand. On bonus questions, you might be ready to graph by hand. You just use a calculator. So if you know how to punch stuff into the calculator, by all means, graph it on the calculator, transcribe it onto your test, but you still need to know everything that the equation is telling you. Because I'm going to expect that you plot points. So that's why I'm putting it over there step by step. Things you have to write down, things you have to look for, things you have to label. Everything's important. The bottom line is the way you first learn how to graph anything at any time. We plug in numbers in for X. We get answers that are the Y's. We plot those ordered pairs. Pick an X, plug it in, find a Y, plot the ordered pair. You find enough ordered pairs, you start to see a pattern. You keep plugging in X's and Y's into the same type of function, and you see it's always going to be the same shape. Sometimes it flips upside down, and we start to realize if there's a negative in front of it, it's always flipping up, it's a reflection across the x-axis. You start to mess with the x coordinate inside. And you start to notice when you change the value of x by either adding or subtracting from it, it's shifting the graph left and right. If I add a number, it's going left. That doesn't make any sense. But when I subtract a number, it's going to the right. It's going like the opposite. But that's happening in all the different kinds of graphs that we do. After the function, if I add or subtract a number, it's shifting the graph up and down. No matter what kind of function you will ever graph, if you learn the basics of what we're doing right here, no matter what you graph, it's going to follow these same rules. You put a negative in front of it, it's going to reflect it across the x-axis. If you change the value of x by adding something to it, it's going to shift it to the left. If you subtract something from it, it's going to shift it to the right. If you add or subtract a number after you do the function, if you add a number, it's going to shift it up. If you subtract a number, it's going to shift it down. No matter if you're graphing a logarithm, an exponential function, a trig function. Those things are always going to be the same. So if you know how to graph the general shape, you're going to know how to graph whatever the crazy looking one. You don't have to be intimidated. You just need to know what the general picture looks like. Instead of plugging in a whole bunch of numbers, you always can plug in a bunch of numbers if you want. But you don't have to. You are STEM majors. You need to step up to the next level. If you don't like graphing, too bad. Graphing isn't part of STEM. It is. It's never going to go away. To get on board. I'm not saying that to be mean or scare you or anything. It's just get on board. It's never going to change on you. That's the one thing in life. Math is never going to change on you. History seems to be changing on you. The economy will change on us. How much money we make per year will change on us. Who knows? Boyfriends, girlfriends, husbands, they change on us. Your kids change on you. Boy, they hate you one time, they like you the next, and then all of a sudden they turn on you. But math is always the same. You've been my best friend ever since I was a little kid. Math has never let me down. Sometimes I let math down because I didn't understand it. It was speaking to me, but I couldn't understand what it was saying. Because I wasn't working as hard as I could. I thought math was easy, then all of a sudden I got hit. Called calculus. You can't think you can skate along until you hit another road. And if you want to stop and say, I can't do this, well, what about the thousands and thousands of people that can? You're part of that. Don't let that stop you. It's called practice. Who are the best players? They get paid the biggest money. Basketball. They're playing in the what? It's got 3 letters. NBA. The NBA, thank you. Making sure somebody's out there. Do they have talent? Yeah, sure. They do have talent. But do they work hard? They work hard. They really have to work hard to be that good. One of the hardest working players, Michael Jordan. And remember, he got cut in high school. And he had to work hard to get to that level. Shaquille O'Neal can't shoot a free throw. They even created a name for the end of the game when Lakers were up. Hack-a-Shack. If you're down and you need to get the ball back at the end of the game, you foul Shaquille. Because he's going to go shoot his free throws, he's going to miss, and we get the ball, and we're going to go down and score. Which I still don't understand why they give the NBA the ball back for. That's wrong. But Hack-a-Shack. Do you think Shaquille O'Neal never practiced his free throws? I bet that's all he ever did. Because it was embarrassing to him. He still practiced. If you're a baseball player, what's a good batting average? Hitting what? Anybody know? Really? Nobody knows what a good baseball batting average is. Does anybody ever watch baseball? Nobody. I'll tell you. 300. If you're a 300 hitter, you have a chance of getting into the Hall of Fame. A lifetime 300 hitter. Okay, I think one of the best players of the Padres, Tony Gwynn, like a 312 hitter. That means out of 1,000 at bats, he only got 312 hits. He failed 88 times. Sorry, 78 times. A 300 hitter, gets out 7 out of 10 times. That's only 30%. Do you think they practice hitting? Do you think since they were little, how many times they've gone and practiced hitting batting cages, mom or dad throwing baseballs to them and all that stuff? Or do they just kind of like, I'm just going to walk up there and hit? If you're going to be good at something, you have to practice. And sometimes being good is just, you're only this far. But that's the level. What do you call a student that graduates from medical school that has the worst GPA of that medical school? Doctor. Because he graduated or she graduated. They're called doctor. There's a class at Cal Poly San Luis Obispo for architects. I think it's called materials. It's a materials class. I had quite a few students that went, graduate from Canada and went on to become architects. First of all, if you're an architect major, it's the only major at Cal Poly that they allow a student to take 5 years. Everybody else, you've got to get out of there in 4 years. That's what they're pushing you for. They don't want you to get out, they want you to be focused. And they really just, don't like you to change majors. 5 years for an architect because they know there's going to be classes that are going to be tough. This materials class, rarely does anybody pass it on the first try. When they sign up for it, they know they're gonna take it a second semester. So it's kind of like you sit there, you gotta audit the class for that first semester, and then you take it again. I had a student, they showed me the architect lab, they said, this is the only lab where lights are on 365 days a year, Christmas Eve, New Year's Eve. There's always somebody working in the architect lab. Some people have little, pillows and blankets underneath their architect table, maybe a fridge, because that's where they live. They're working on projects that take 2 or 3 years to get done so they can get their degree. When I did some NASA presentations when I was teaching high school, the physics teacher graduated from Cal Poly. His roommate actually is an astronaut with NASA. He graduated from Cal Poly as an electrical engineer. This was in the early 80s. His roommate is the first person to graduate from Cal Poly with a 4.0 in engineering. And it wasn't until the 80s. Which means, guess what? You don't have to be a 4.0. What you have to do is you have to be a hard worker. My best friend growing up is a doctor, an ER doctor in Visalia. I had better grades than him in high school. But when I came to college, I never saw him. He worked his tail off all semester. He went to Cal Berkeley. He worked his tail off all school year long. And when spring break hit, he went to Mexico or he went somewhere out of the country. He was off. Summer hit, his brother lived in Indonesia, his sister lived in Mexico City. He was traveling the world because he just took that time. He earned it. He wasn't going to mess around during the school year, but he earned it. And that's the mentality. Becoming a doctor is not about how smart you are. It's about perseverance. Can you take it? And what you want is a doctor who can take it. You want a doctor who can actually get through all of that. Sometimes the smartest people aren't going to be the ones that do the best thing because they're too smart. If you struggle with graphing, then don't just sit back and go, all right, you know what? I'll wait till this is over. Then maybe we'll be able to do something I like better. It's not going to go away. You get what we're doing here, all these little pieces that change this function. It will apply to every kind of function you will ever graph. You learn it here, you got it down. Okay? I give this little talk every single semester. Take it to heart. So when we substitute into the x squared, especially the negatives, you're going to need parentheses. So -3 parentheses, and we square it. We get -3 times -3. When you square a negative, it's going to be a positive. We get +9. -2 squared is going to give us +4. -1 squared, we get +1. 0 squared. Now you don't need a parenthesis because it's not negative, technically. It doesn't hurt. So if I put a parenthesis every time, I'll make sure I put a parenthesis when I absolutely need it. I get 0. This is what I'm talking about. If you put -3 without the parentheses and you square it, and you get the correct answer, you get +9. I'm taking off a point. Because this -3 squared without a parentheses does not equal +9. This -3 without parentheses equals -9. Because you're not squaring the negative unless you have a parenthesis. What this is negative and then 3 times 3. There's one negative and you're multiplying 3 times itself. And that's why it's equal to negative 9. So if you are plugging in or substituting a negative into the parentheses, you're going to square it like that. And that's how we get positive 9. Good. It matters. And until you start taking, until you start understanding that, until you start taking those details and writing those details every single time, you're gonna start, you're gonna keep either getting it wrong, not making sense, wondering why am I, why is he always picking on my problems here? Because I'm not gonna stop. Yeah, is it a nitpick? No, it's not, because that's wrong. This is absolutely incorrect. It does not equal positive 9. I'm not going to let you get away with it. Oh, but come on, let's go. Come on, isn't it? You just want to. No, it's not. It's not true. Okay. Math will never let you down. So 1 squared, 1, 2 squared, 4, 3 squared, 9. And if we look, we see some symmetry. 9, 4, 1, 0, 1, 4, 9. 9, 4, 1, 0, 1, 4, 9. The ordered pairs, because that's what we have. We have them. X that goes in, negative 3 went in, positive 9 came out. Negative 2 went in, we have a 4 that came out. Negative 1 goes in, we have a 1 that comes out. 0 goes in, 0 came out. 1 goes in, 1 came out. 2 went in, 4 came out. 3 went in, 9 came out. Ordered pairs. So we can plot them and graph. Then we change what's going on with the function. Instead of just squaring the x, we are going to, before the square happens, add 2, square it, and then take away 1. We're going to add 2, square it, and then take away 1. So, parentheses, negative 5 plus 2, we're going to square that, and then you take away 1. So in here, negative 5 plus 2, that's negative 3. Squared, and then we take away 1. So that gives us positive 9, and then minus 1. So that gives us positive 8. So the ordered pair, negative 5 went in, positive 8 is the y value. So look at the comparison. When we plugged in negative 3, we squared it, that's when we got the 9. In order to get the 9, we had to plug in negative 5 for x in order to get the actual 9 that came out of our square. And the reason why is because of the plus 2. We don't get the 9 until this equals a negative 3. So what plus 2 makes that negative 3? X has to be a negative 5. That's when that becomes a 9. Just like this became a 9 when you plugged in negative 3. Which means when this x is negative 3, something happens. But the same thing won't happen until we plug in negative 5 because of that plus 2. And the best way to show this, and let's take a look at this. And I will have to move these out of the way. So over here, -3.9. -3 again, and that's when we got this number. And that's f of x in red equals x squared. -3.9. The corresponding point in blue, we plugged in -5 and we got -5.8. So the same point that corresponds to this one in this other graph is at -5, +8. So in blue, this is g of x equal to x plus 2 squared minus 1. This point in the original function has now been shifted over to this point here. So we're going to compare everything when everything gets plotted. All right. -4 goes in. -4 plus 2. And then we're going to square it and then take away 1. -4 plus 2 is parentheses -2 squared. And then we take away 1. So -2 squared is +4. And then we take away 1. And 4 minus 1 gives us 3. So -4 goes in. -4 goes in. And +3 came out. So on this one, we plugged in -2, we got 4. -2, we got 4. Over here, when we plugged in -4, we got 3. You see how this one in red compared to this blue? This blue one is to the left 2, down 1. This one in red to this one in blue. The positioning is to the left 2 and then down 1. The change from the original to where we are now, it went left 2, down 1. Left 2, down 1. Look at the new equation. Look at the new function. Something with a 2, something with a 1. There's a pattern going. Plug in 3. So in the parentheses, -3 plus 2. And then we square it and take away 1. -3 plus 2 is parentheses, take away 1. That's a -1 squared. And then we take away 1. So -1 squared is +1 minus 1. And then 1 minus 1 is 0. So when we plug in 3, -3, we get 0. Here, it was -1, 1. On the original, it was at -1, 1, right there. Look at the pattern. Going left 2 and down 1. So the pattern says left 2 down 1, left 2 down 1. So if the pattern continues, I should have gotten here -3, 0, and look what came out. -3, 0. The reason why we need functions, we gather information, we collect data out of the world. And we are able to write it out as a mathematical equation, a function. So we can plug in future dates and predict, hopefully, what will happen. Okay. That's the whole point about mathematics, is so it gives us a way to understand what's going on around it, so we know what to expect. Hopefully, if the equations hold, what will happen in the future if it continues the pattern. So the pattern says, if this is 0, 0, this one is here at the origin, the pattern holds, it should go to the left 2 and down 1. It should go, sorry, left 2 down 1 is right there. Left 2 down 1, so I should get this point, which would be at -2, -1. So let's see, I plug in -2. So -2 plus 2, square it, and then -1. -2 plus 2 is 0. Square, take away 1, which is 0 minus 1, which equals -1. So when we plug in -2, sure enough, we get -1 as our ordered pair. The next point is at 1, 1. And we talked about this on Monday. This graph, x squared, the parabola, it comes down, it decreases. And then once you get to this point, what's that point called where it changes? Then it starts to go back up. What's that called? Well, that location is called the origin. But on the graph where it changes, that most important point, vertex is called the vertex. Yeah. So this is at 1, 1. So on the new function, the point should have been shifted left 2 and down 1. So when I plug in -1, I would expect to get -1, 0. -1 plus 2. Squared, take away 1. And then that gives us +1 squared -1, which is 1 minus 1 is 0. So when we plug in -1, 0 comes out. -1 goes in, 0 came out. Zero plus 2 minus 1, 2 squared minus 1. That's 4 minus 1, which is 3. So when 0 goes in, we get 3. Zero goes in, we get 3. But I also want, I didn't plot the red one yet, but I want to show you something. You see how the blue has a lowest point, and then it goes back up? This graph, the parabola, has symmetry to the left and the right of this vertex. Everything on the left side should mirror with something on the right side, something vice versa. So to the left of the vertex at -4, the y value is a 3. So this is -2. This is -4, 3. So if I go 2 to the left, that's a 3. So therefore, if I go 2 to the right, that should be a 3. To the left 2, I get a 3. To the right 2, I should get a y value of 3. Symmetry, left and right. So again, now you can predict instead of plugging in. If I go 3 to the left, 1, 2, 3, I'm at -5. 3 to the left, I get an 8. So if I go 3 to the right, 1, 2, 3 to the right, I should be right up here at 8 as well. That should be at 1, 8. Because everything that's going on to the left of the vertex should happen to the right of the vertex. Symmetry. Likewise, we should also have symmetry on the red one. 1 to the left of the vertex is 1. 1 to the right is 1. If we go 2 to the left of the vertex, we get 4. So if I go 2 to the right, that should be a 4. When we went 3 to the left, we got 9. When we go 3 to the right, we get 9. And if you look at all the comparisons, I know you got like reds and blues everywhere, but the shift of those reds and blues is 2 to the left and 1 down. So right here, this one, 2 to the left, 1 down. This red to this red, 2 to the left, 1 down. This red and this blue, sorry, this red, this blue, 1, 2 to the left, 1 down. This point is this point, 1, 2 to the left, 1 down. This point and that point are connected, 2 to the left, 1 down. So I don't want to plug in a whole bunch of set of numbers because what if I have to do, you know, Q of X is equal to 3 times X minus 18 squared minus plus 1.7. I don't want to plug in a whole bunch of numbers just to graph that. I know what the 3 tells me to do with it. I know what the 18 tells me to do with it. I know what the 1.7 is going to tell me. Here's what happened. That plus 2 moved everything 2 to the left. Every point went 2 to the left, 2 to the left. And the -1 shifted everything down. 2 to the left, 1 down. 2 to the left, 1 down. 2 to the left, 1 down. And the most important points that you compare are the vertices, the vertexes. So your parent graph, and it's really difficult for me to draw it all in one, one without picking up the pencil from the paper. I just basically draw the left branch through those points, and then I'll draw the right branch to that point right there. That much. And so when we get to 10 o'clock, I'll put this back up here. But on a parabola, the standard equation is f of x is equal to, we did this Monday, a times parentheses x minus h squared n plus k. And we talked about what a does. A flips it across the x-axis. So if a is positive, it's open up. A is negative, it's open down. But for right now, hk is the ordered pair of the vertex. So that whatever h is and that whatever k is the ordered pair, and that's where the vertex is. But when you extract H from this parenthesis, there's a built-in negative inside that parenthesis. So when you figure out or trying to take the H out, it's the opposite sign of what you're looking at. Right here, the vertex was at -2, 1. For this graph. Was at -2, -1. I see +2, but the vertex was -2. So you got to remember you're going to change the sign on that H. And I've been saying it like this because you got to find a way to remember. It's the opposite sign for the H. Because it's a built-in negative. It's the opposite. H for opposite. For the K value, you keep the sign. Keep the sign for K because you're going to add it. If I add a positive, it stays positive. So if K is positive, it's plus. If K is negative, then you would see minus. This would be plus a -1. So K is a -1. It's just written as -1. So you keep the sign on the K. You change the sign for the H. So you just got to figure out, make a list. What is A? What is H? What is K? That tells you where the graph goes, and that tells you if it's up or down. Now, if I change like the right of parallel 3, if the number's getting bigger, and we're not going to worry about it right now, but the number's bigger, like bigger than 1, it makes it more narrow. If the number's a half, it makes it wider because it's only going up half as quickly. But if I put a half in front of bx squared, then instead of getting a 4, I would only get a 2. So it's going to widen out the graph. Okay. But if I put a 2 in front of it, when I plug in 2, I would double the 4 and I would be up here at 8. So it would be a lot higher, a lot quicker, and it would narrow the graph. Now, for the absolute value that I have up there, and for the square root that I have up there, we're going to do those at 10. So I gave you a little head start because right now, the last 15 minutes or so, I will not do your quiz questions, but if you have something comparative on the quiz preps, you can ask, and I will do. Before we turn the quiz. I also pull up the quiz prep that we did in class on Monday in here in Kodak. You tell me that and I'll be putting things up left and right and you'll say, no, not like that. I grew up in a household of never being able to do anything right. So when you ask, can you do one like, and I'll go, nope, because you have to be specific. So this is the quiz that the quiz prep that we did in the correct on Monday, and then these are the two from that I sent home. That one, that was the first quiz prep. That was the second one, we'll have that bonus, and then that was a win-win. But we are now at 10 minutes left. On this? Okay. You want to see the first question? So this one. All right. So we want the domain. So the domain is about what we're allowed to plug in. You can't divide by 0. So who's invited to this function party? Everybody except whatever might make this denominator 0. So you got to figure out who is the troublemaker, who is not allowed. You'll let 5x plus 8, you'll let it equal 0. And you solve. We would subtract 8. And we end up with 5x equals negative 8. Divide by 5. And if x is equal to negative 8/5, this would be 0 in the denominator. So therefore, x can equal everybody except that negative 8/5. On a number line, it would look like this. There's 0. Negative 8/5 is over here. And what can we plug in? Everything to the right and the left of the negative 8/5. This is the domain. That's the picture. Everybody except this. You have to write the domain using interval notation. You have to write it using interval notation. So what is shaded? Everything is shaded from negative infinity all the way up to negative 8/5. Close the parentheses. Join together so it's a union. This set of numbers, union, the numbers to the right of negative 8/5, so parentheses, negative 8/5, all the way to positive infinity. Infinities are always parentheses. And because it does not equal the negative 8/5, that is also a parenthesis. Versus what? Well, okay, so the first thing, so we're solving for x, right? The last thing I'm going to do to get x by itself would be divide by 5. So I have to get the 5x by itself before I can actually divide by 5. So I have to get the 8 on the other side, and then what am I going to do? I'm going to divide by 5. Well, I only care about the bottom because I'm trying to figure out the domain. The numerator can equal 0. It doesn't matter what the numerator is for the question of domain. The domain is what is allowed in the function. So what can the denominator, what is allowed in the denominator? Everybody except a possible 0. So the question is, who would make 0 in the denominator? If x is equal to negative 8/5, I'm going to get 0 in the denominator. So x cannot equal negative 8/5. It can equal everybody except that. What? Anything else? Yeah. 1C. 1C. So we have five minus 2x squared. E of x is equal to parentheses 5 minus 2x squared. And for 1C, we want to do what is g of x minus 2. So I was very explicit about what I want to see from you. I want to see the substitution, then the simplification. So the first thing I would have to see is, what does this look like when I substitute this x with an x minus 3? If I replace that x with an x minus 3, then all the x's get replaced with an x minus 3. So I'm going to get parentheses 5 minus 2 times. And that is now going to be 2 times, this is now going to be an x minus 3 instead of just an x. And then you're going to square it. So order of operations, you would simplify what's in the parentheses before you square it. So we get 5, distribute the negative, minus 2x plus 6. And then you're going to square it. Simplify before you square it. You still have something you can do. This is equal to 5 plus 6. You can either write it as 11 minus 2x and then square it, or you could write negative 2x plus 11 and then square it. It doesn't matter, you'll get the same answer. You can multiply it using the special product, or you can multiply it together just by distribution. 11 minus 2x times 11 minus 2x. So 11 times 11. I'm going to write it out. 11 times a negative 2x, so that would be negative 2x times an 11. And then negative 2x times 11, so that would be a negative 2x times an 11. And then a negative times a negative, that's going to be a positive. And we get 2x times a 2x. Eleven times an 11 is 121. Minus 2x times 11 is minus 22x. Minus 2x times 11, that's another negative 22x. Plus 2x times 2x is 4x to the second. So the last thing you have to do is simplify, combine your like terms. X squared should go first. 4x squared. X to the first, negative 22x, another negative 22x, that's negative 44x. And then a positive 121. Yes. From the first quiz prep, the second quiz prep, or the one we did on Monday? We have 3 minutes. This one right here, this one? The second quiz prep. So this one? Which one? Yep, minute and a half, 2 minutes. 1B, okay. G of negative 10. So this goes in with what we're doing now. We have 10 minus x squared, and we're plugging in negative 10. Substitution. G of negative 10. So 10 minus, and when I substitute a negative, parentheses. So x is now parentheses negative 10 squared. So this equals 10 minus negative 10 squared is positive 100. That negative is not being squared. Only x is being squared, so when I square -10, I get 100. It's 10 minus +100, which is -90. If you're going to get the full credit, I have to see exactly the substitution. I need to see this step and then the simplification. If you just go right to here and going, well, how'd you get that? You're not going to get full credit. You might get half. I have to see the substitution. Talked about that. Okay. Back at 10. And when we, at 10 o'clock, I will collect the quizzes. So you're not going to just bring them up, I will collect them.